The world is full of horror, mystery. Among them are some of the most powerful and dynamic events known to science: supernovae. These massive stellar explosions produce more energy than a billion suns in an instant and emit large amounts of radiation across the energy spectrum, from radio waves to gamma rays. These explosions are so powerful that, in theory, the entire world will one day feel the effects of the explosion. The discovery of the James Webb Space Telescope, JWST, man's newest instrument to observe the universe, has excited the scientific community. The star Betelgeuse, a prominent and popular star in our night sky, is showing signs of an impending supernova. Are we about to witness one of the most amazing events of our lifetime? Before getting to the mystery surrounding Betelgeuse, it is important to understand the importance of another important event in planetary history: the supernova explosion SN 1987A. This event is a key reference point for understanding the life cycles of giant stars like Betelgeuse and the tragic but beautiful fates they face. The cosmic benchmark supernova SN 1987A, discovered in 1987, was one of the brightest and closest stellar explosions seen in centuries. This galaxy is 168,000 light-years away in the Large Magellanic Cloud, a galaxy in the Milky Way. During the explosion, SN 1987A released so much energy that it was visible to the naked eye from Earth. Since its first discovery, astronomers have tracked the expanding supernova remnant, using it to understand processes affecting the evolution and death of stars. What makes SN 1987A so important is that it has been carefully observed using various space probes, such as NASA's Hubble, Spitzer, and Chandra telescopes. Now the James Webb Space Telescope has taken this research to a new level. With its unique ability to see in the infrared, JWST has captured the most detailed images of SN 1987A's structure, including its equatorial and outer rings, a crescent-shaped inner ejecta, and the odd shape of the main hole inside. One of the most interesting features of SN 1987A is its inner equatorial ring, formed by debris ejected from the star tens of thousands of years before the supernova event. When a supernova shock wave hits the structure, bright hot spots appear, visible in JWST images. The telescope also found quaternary-like structures in the outer layers of the atmosphere, possibly remnants of an ancestral explosion. The explosion, perhaps the end of a super-blue star, one of the most massive and brightest stars in the universe, will serve as a planetary laboratory. By studying SN 1987A, scientists have been able to piece together the last moments of the star's life and draw conclusions about the fate of future supernovae, including Betelgeuse. Betelgeuse, in the constellation Orion, is one of the brightest stars in our night sky. It is also one of the largest, 900 times the diameter of our Sun. If it is in the center of the solar system, the outer surface is outside the orbit of Jupiter. Betelgeuse is a red giant, a massive star at the end of its life. Astronomers have long known that Betelgeuse explodes in a supernova event. However, Betelgeuse hit the headlines in 2019 and 2020 with an unexpected start. Although stars such as Betelgeuse can vary in brightness, the rate and extent of dimming has astronomers worried. The faint event, observed by several instruments including the James Webb Space Telescope, raised questions. What could be the cause? Is this a sign that Betelgeuse is on its way to a supernova? Several theories have been proposed to explain Betelgeuse's sudden dark appearance. One theory is that it is caused by a large cloud of dust passing in front of the star. As massive stars like Betelgeuse age, their outer layers are depleted and produce dust and gas. This ejected material can obscure the star's light, making it appear dark from our location on Earth. Another possibility is that Betelgeuse is associated with shooting stars. Massive stars go through many periods of expansion and contraction. These bulges can grow and shrink the star, changing its brightness as the outer layers move closer or further apart. But the most intriguing theory is that a blackout could be the start of a supernova. Betelgeuse, 20 times the mass of our Sun, is nearing the end of its life. When the fuel runs out, the core collapses under its own power, causing a massive explosion. In the past, stars have been found to undergo abnormal contraction before exploding in supernovae. Could Betelgeuse be close to such an event? The results of the Betelgeuse supernova are surprising. If Betelgeuse explodes, this supernova will be one of the biggest astronomical events ever seen in human history. This explosion can cause the moon to explode so bright that it can be seen from Earth even during the day. For weeks or months, Betelgeuse will shine above all the stars in the night sky, becoming a beacon in the sky. But this explosion goes beyond the visual aspects. Supernovae release large amounts of energy in the form of radiation and energetic particles. The gamma rays produced by the supernova Betelgeuse can be seen all over the world. But given Betelgeuse's distance from Earth, about 642 light-years, the radiation does not pose a threat to our planet. The shock wave from the explosion also travels through space, compressing the interstellar medium, creating a fiery bubble of ionized gas that persists for thousands of years. The region around the ejecta is enriched with elements such as carbon, nitrogen, oxygen, and metals, essential for the formation of new stars, planets, and potentially life. Astronomers have the opportunity to study a nearby supernova in real time. The data collected provide a better understanding of the life cycle of massive stars and the mechanics of starbursts. Observing the death of Betelgeuse may help us understand the fate of other large stars in the universe, as well as the formation of heavy matter for planets, moons, and life. Betelgeuse's fate is one of the most fascinating and mysterious in the modern universe. Accurately predicting the timing of this eruption is not easy. Massive stars like Betelgeuse are unstable at the end of their lives. Although astronomers know how stars grow and die, it is difficult to determine the exact time of a supernova. One reason for this surprise is the complex physics involved in Betelgeuse's core. As the star burns through its core fuel, it enters various stages of fusion, gaining more mass. As the star begins to fuse iron into its core, it collapses and goes supernova. However, it is very difficult to determine exactly when Betelgeuse will start to melt iron and explode. The faint event that occurred in late 2019 and early 2020 has led to widespread speculation that this supernova is imminent. The star's brightness dropped by more than 60% in just a few months, leading many to believe that collapse was imminent. Dubbed the Great Anomaly, this phenomenon caused a wave of observations and theories. Some scientists believe Betelgeuse's appearance is a sign that it is entering its final stages, while others believe it is due to surface activity or dust clouds obscuring the star's light. In our view of Earth as a natural luminosity, the event revealed the unexpected nature of the star's behavior. This obscurity is a reminder that large stars like Betelgeuse can undergo dramatic changes in a short period of time. Astronomers are turning to advanced space instruments to better understand Betelgeuse's features. One of the most important instruments for this task is the James Webb Space Telescope, JWST. Equipped with advanced infrared sensors, JWST can observe stars and other celestial bodies in unprecedented detail, by studying Betelgeuse's emission of light, heat, and radiation. Scientists hope to learn more about its inner workings and whether the supernova may be closer than we thought. JWST's sensitivity to infrared wavelengths allows it to detect subtle changes in the star's environment, giving astronomers a clearer view of changes that could indicate an explosion is imminent. In addition to monitoring Betelgeuse's brightness and temperature, the telescope can also check the star's brightness. By doing this, astronomers can determine the chemical composition of Betelgeuse's atmosphere and the rate at which it is ejected. This information helps scientists track the evolution of the star and estimate how long it will take for the core to collapse. If Betelgeuse is approaching the iron fusion point, the JWST instruments may be able to detect this transition, providing the first real evidence that a supernova is imminent. If Betelgeuse is approaching supernova status, astronomers hope to see telltale signs before it explodes. One of the main signs is the star's rapidly increasing neutrino output. Neutrinos are nearly massless subatomic particles produced in large quantities during nuclear reactions in stars. When a star like Betelgeuse begins to collapse, its parent emits a burst of neutrinos. Seeing this influx of particles is a strong indication of the occurrence of the supernova. Although neutrinos are difficult to detect due to their weak interaction with matter, there are many underground neutrino detectors around the world, such as Supercamiocandy in Japan and IceCube in Antarctica, are still looking for these complex particles. If Betelgeuse starts emitting neutrinos at a faster rate, these observers will be the first to know. A result. Betelgeuse's future remains uncertain, but its fate is sealed. Whether a star goes supernova tomorrow or in 100,000 years, one thing is clear. The explosion is a major event in the universe.